Thank you, everyone, for joining us for this webinar. We're going to give it another minute or two. We have some people still signing on, and then the webinar will begin shortly. Thank you, everyone, for joining our anaerobic operator webinar series for today. This webinar is entitled Preventing Upsets in Your Anaerobic Reactor. My name is TJ Willits, and I'll be your moderator for today's webinar. It's something that we're really excited to share with you because we believe it'll help provide you with some great information to not only prevent upsets in your reactor, but also help you to troubleshoot if some problems would occur. Just some housekeeping before we hand this over to our presenters. There are a few audio options. You could either use your computer audio or you could call in on a conference call line. The webinar is being recorded and will be shared to those who are in attendance after the webinar is over. And there will be a question and answer session after the presenters are done. If you could just catalog your questions in the questions panel on the right-hand side of your GoToWebinar screen. We'll try to get to as many questions as possible later on in the webinar. So after the webinar, you'll be provided to a link to a survey, and it'll also be in your follow-up email to the webinar. Please take a few moments and fill that out. The main purpose of that is to help provide some content for us to present on in future webinars. So we look forward to having your feedback so we could go ahead and shape the content and provide webinars that are as meaningful as possible to you. Also, the survey is your means to request a participation certificate. If you're attending these webinars and would like to have educational credit for it, make sure you fill the survey out and check the box to request a certificate, and we'll make sure that we email one out to you. So at this time, I'm going to introduce our speakers. Our first speaker for today's webinar is Greg Rosenberger. He is the Technical Director of Veolia's process team. In his role, he's responsible for developing solutions for industrial wastewater applications, including the process selection, the system design, mass balance, laboratory and pilot testing, and startup of all of our facilities here. He has over 20 years experience in biological wastewater treatment in a broad range of industries. Also, would like to introduce Jill Jordan, who many of you know. Jill has over 35 experience in the anaerobic treatment of industrial wastewaters. She probably is single-handedly the most experienced in preventing wastewater or presenting upsets in anaerobic reactors, and also helping customers fix those issues and get them back online. So without further ado, I'm going to pass this webinar over to our first speaker, Mr. Greg Rosenberger. Greg, are you with us?
Yes. Thank you, TJ. So just to review the agenda for this webinar, this is the third webinar in a series. We're just going to quickly touch on what we talked over in webinars 1 and 2. We're going to look at the 5 different things that can cause an upset, and then we're going to look at the different things that we can do as operators to help try to prevent those upsets from occurring, or when they do occur, how to get out of them as quickly as possible. So our first webinar we had was just a sort of a 101 on biology and chemistry of anaerobic systems. Anaerobic digestion involves a lot of different type of bacteria, primarily acid-forming and methane-forming bacteria. The methane formers are the most finicky of those bacteria. They're the most sensitive, so we like to keep them in harmony. And we talked over how the key to anaerobic treatment is really controlling the system, the amount of COD or food it's fed, the pH, the temperature, nutrients, and to make sure there's no inhibitors or toxic substances coming down the drain. The second webinar, we looked at some different operational efficiencies of the different systems, the different types of reactors that we had, what type of testing, laboratory and physical testing should be done, and went over how those tests were done, essentially VFA, COD, TSS, pH, temperature, and nutrients. So now we're going to sort of start our third webinar looking at anaerobic reactors and what causes them to get upset. And the first thing to look at is what causes them to get upset is how do you know if they are upset in the first place? And the first thing that we look at is a test that you should be running on a daily basis is the VFA, the volatile fatty acid test. Typically, we like to say that if the system has less than 5 milliequivalents per liter of VFA, then the system is relatively stable. If the VFA gets higher than 5 milliequivalents, some different things that you can look at doing is reducing this SCOD load. You could have a washout of biomass. You might see your biomass start to turn color. If it's a blackish color, turn to gray. So it's important that you do the VFA. If you do only one test, so you should be doing more, as Jill told you, but if you do one test, make sure you do that VFA test daily. So what are the 5 major things that can cause an upset? These aren't the only things, but these are the 5 major things that cause an upset. And they are overloading of the biomass or overfeeding to the system, your pH getting out of range, your temperature getting out of range, lack of proper nutrients in the system, such as nitrogen, phosphorus, or your micronutrients, or something toxic or inhibitory came down the drain from the production facility that killed or partially inhibited your biomass activity. So here's a flow chart. It's rather complicated, as you can see. We're going to go over this in more detail, as Jill is in the ensuing slides. But this is the type of chart that might not be a bad thing to just have sitting on your desk or tacked on the wall to use as a tool when you start to have some issues, just to think through yourself. Here are the different things I should be thinking about. Here are the different things I should be looking at. Maybe you actually jot some notes on this tool to show where your ranges are when you're running well. So this is just a flow chart just to sort of get your juices flowing when it comes to starting to troubleshoot an upset condition. So I'm going to turn it over to Jill now, and she's going to really go over the details of troubleshooting and some experience that she's had in her previous 30 years of digester operation. Jill?
Yeah, thanks, Greg. If you notice, the first question on the flow chart was, is the system overloaded? So how do we know that the high VFA that Greg talked about is caused by overloading? Well, your F to M is going to be higher than it normally is. I can't give you a number on what, if it's higher than 0.3574, that it's a problem, because everybody runs at a different F to M. But if your F to M, if you're doing your test and you find out that you have a high VFA and the F to M is like 50% or 100% higher than it normally is, that's probably the reason for your problems. The thing you want to do is you want to check, have you lost sludge? I mean, is that what caused it? Did you lose sludge? But you should have known that, because you should be checking the sludge profiles, or the amount of mixed liquor suspended solids in your system at least weekly, to know that you have enough sludge in your reactor. You also want to look at the volumetric loading rate. Did an extra amount of water come down the day before that caused the some extra loading? Was there some extra COD that came down? So those are things you want to look at. So if I find out that I have overloaded the system, how do I fix the problem? Well, first of all, obviously find the cause. And if it is overloaded, you want to reduce the loading rates as soon as you possibly can. And that means, if possible, diverting the influent. I know not everybody has that capability, but you might, if you have a big EQ tank, you may be able to hold up there. You may be able to divert to the city for a while. If you're lucky, you're able to do that. If you've lost sludge, you want to add more sludge. If you have a sludge tank available and you have excess, if you carry extra sludge in there, do that. And you always don't want to make any increase in loadings until you get the VFA in the effluent down to below 5 milliequivalents per liter. Next. So what could cause a big sludge loss? That was one thing that we said could be one of the problems. Usually it's something like fats, oils, and grease have come down, which cause the sludge to float out. Or it could be that there's a mechanical issue. Our high rate systems have a settler in the top. If there was a problem with the settler, that could be an issue and cause a washout of sludge. If you have a lower rate system that's returning sludge via a clarifier or a dissolved air flotation unit or a centrifuge, any one of those could be have a problem and cause a lack of sludge return and a loss of sludge. And it could also be due to a toxic spill. So obviously, if a mechanical issue is the problem, you want to stop that problem by keeping the equipment maintained in a good manner and keep the mechanical problems at a minimum. Next. So let's say you have enough sludge in there, so that's not one of your issues, but that would lead you to believe that the influent COD load was very high, and so then you have to find out where it came from. If there was a spill in the factory, you want to get them to try and stop it as soon as possible. Let's say this could be anything, like if you're in a brewery, if somebody opens the bottom drain on a fermenter and you spill, 10,000 gallons of beer down the drain, you want to find that as soon as possible and get it stopped as soon as possible. It could also be things like sugar, or if you're in a jelly manufacturing plant or soft drink manufacturing facility, there's sugar all over, and it could be something like that. Again, you want to stop that as soon as possible. Find the cause and get it stopped. And then again, you want to keep the loading down in the reactor so that the bacteria have a chance to recover until the VFA gets down below 5 milliequivalents per liter. Okay? So how do you keep this from happening? Well, you can't keep it all from happening because accidents happen. But it's always good to set up a good communications with the factory. You operators should really try to get good relations with all the people up in the factory so that they know to tell you when something's coming down the drain. Often, if you just have a heads up on something, you can take precautions and take steps to eliminate or reduce the severity of the issue. A lot of this now can be stopped by automatic controls. We have Veolia has this system now called Aqua Vista, which has a lot of online alarms and signals where problems, especially even overloading situations, could be reported to anybody automatically. And the controls are set up such that if something did go wrong, you can actually stop the system and protect the sludge. So automatic controls and keeping them up and running are really, really important. And as we said, it's also very important to keep the mechanical issues at bay by doing preventative maintenance all the time. Keep the equipment in good working order, have spare parts on hand, and make repairs as soon as possible. So that's the first problem, overloading. So let's say you checked everything, the system's not overloaded. So now the next most likely problem could be a pH. So what can cause high pH? Well, you know that it's going to be, the pH is high, number one, because the effluent in the reactor effluent pH is high, or low. It could be high or low. In most cases, it gets to be too high because of a spill, or too low because of a lack of control. So just remember that the optimal pH is 7.2. Now, I know that not everybody operates their reactor effluent pH at 7.2 because that costs a lot of money for caustic most of the time. So a lot of people, I know a lot of systems run lower than that, 6.8, 6.5 even. And if you're running below that optimal level, you have to be really careful that your control system is really spot on because you're running on the edge. Okay? So what can cause the pH to go out of range? It's usually pH control equipment failure. This could be a bad pH probe, a broken caustic or acid pump, or the loss of pH adjusting chemical. You can run out of caustic, you could run out of acid. Or it could be a spill of one of those chemicals up in the factory. And if you have an overload situation, you could also run into an acidification problem because remember that the acid formers have the ability to outproduce the methane formers. So they're going to, if you have a lot of extra food, the acid formers are going to keep making acid, and eventually they could cause the pH to drop. Next. So how do you fix the pH problem? First, if it's a mechanical issue, obviously you have to fix that. Then work to get the pH back in range as soon as possible. If it's a spill from the factory, there isn't much you can do but to try to get the pH adjusted back as fast as possible. It's often helpful if you rinse the reactor with clean water to get the system pH back faster. And remember that if the pH is either too high or too low, that means that the activity of the biomass is going to drop off. So you're going to have to lower the loading again to reduce the VF, to get the effluent VFA down below 5 milliequivalents per liter. If you have a pH problem and the bacteria has been damaged, the fastest way to recover is to reseed the reactor. And I know nobody wants to do that, but it's going to be the fastest way because remember, those methane-forming bacteria, if they're damaged, don't reproduce really fast. So it takes a long time to recover from that. It would be a lot faster to reseed. Next. So how do you keep this from happening? How can I reduce the possibility of there being a pH problem? I can't emphasize enough how important it is to keep the pH control equipment in good shape. This means that the pH probes should be checked. The inline pH probe should be checked daily and cleaned and calibrated as required. The pH control equipment, whether they're individual loop controllers or a control package of part of a PLC. I just recently had a customer where the controller went out of whack, and the pH in the reactor got down to 5.5. The operator had requested help from IT people and from management to come fix it. It took them a week to get out there. That's not right. You really need to get those sort of problems fixed right away. Also, operator error can be a problem. If you're not calibrating the probes like you should, that's an operator problem. Also, I can't tell you how many times I've heard about customers having a pH problem, and my first question is, did the alarm go off? Because most 99.99% of our plants now have control packages where alarms are set, and the operator has the ability to change the alarm set points. And there should always be a high alarm and a low alarm that somebody should see and should acknowledge and should be able to then take action before you get to a high or a low alarm. And then the controls, if they're not in auto, the interlocks that might happen at high or low instances, which would shut the system down, don't work unless everything's in auto. And so that's another thing you got to make sure that you do. Keep everything in auto. Again, have good communications with the factory so that you know if there's an acid or caustic spill, and then you have a chance to catch it before things get bad. And again, your controls, keep them going. Next is temperature. Similarly, you'll know that temperature is a problem if you come in and your reactor effluent temperature is way higher than it normally is or way lower than it normally is. And remember that the optimal temperature for the methane-forming bacteria is 98 Fahrenheit or 37 Celsius. And remember also that the lower temperatures aren't as bad as a high temperature. Remember that In a lot of the food and beverage industry, they do CIPs with hot caustic. Again, hot because the high temperatures, as you can see with this graph, cause problems with the bacteria very rapidly. And again, the high pH causes bad problems. So, next. So what could cause the temperature to be out of range? It takes a lot of energy to change the temperature of the water. So this isn't as likely as like the pH control problems are. And most likely, a temperature problem is due to an equipment failure. And this could be a bad temperature probe. I haven't seen that very often because they're pretty hardy pieces of equipment. It could be a hot water circulation pump that's bad, or a clogged heat exchanger, or a steam sparger that's broken, or even a boiler failure. Or it could be a release of very hot or very cold water from the factory that was unusual. Next. So how do we fix this problem? First, if it's a mechanical issue, obviously you want to fix that. If a temperature anomaly originated in the factory, there isn't much you can do but to try and get the temperature back as fast as possible. Get your heat exchanger or whatever you're using to get the temperature up or down. And remember, again, if the temperature goes way down or up, the activity of the biomass chain is reduced, and that means you got to reduce the loading to the system until the VFA gets down below 5. Okay? So how do we keep that from happening? Keep the temperature control equipment in good shape. It's really important, again, to maintain your temperature control equipment such that it doesn't break down. Do preventative maintenance. Also, acknowledge and respond to any alarms that you get. Again, most of the problems, if there was a temperature, it would be, I keep calling it operator error, but it's not just the operator, it's failure to maintain equipment. It's not maintaining the probes, ignoring alarms, or not having the system control in auto. And again, that could be an accident. Somebody was working on something and put some controls in manual to test something and then forgot to put it back in auto. Something, check every night before you go home. Is everything in auto that's supposed to be in auto? Again, if you have the system in auto, you can set your alarms and interlocks appropriately so that the system would shut down before the bacteria were damaged. Again, good communications with the factory are really helpful to help ease these problems. Next. Okay, so we're going down that flow chart, and we know the system's not overloaded. The pH is okay and the temperature's okay. So the next thing you want to check out is the nutrients. How would we know that the nutrients were causing, a lack of nutrients was causing the effluent VFA to be high? On the macronutrients, it's pretty easy to tell because we just want to check to make sure that the ortho P in the effluent is greater than 5 milligrams per liter, and the ammonia nitrogen concentration is over 10 in the reactor effluent. On the micronutrients, it's harder to tell because it's not something you're normally testing every day. In fact, I don't think anybody tests it every day. Usually you want to keep these, you want to test these micronutrients once or twice a year to make sure that they're okay. And as long as you're adding them, that shouldn't be an issue. Next. So what could cause a problem with the nutrients? Most likely the failure of the nutrient dosing equipment. It's very rare that you have too many nutrients causing an issue. It's almost 99.99% of the time it's a lack of nutrients that's a problem. So you would have the failure of some dosing equipment, a dosing pump, or you would run out of nutrients. Or it could be a change in the wastewater characteristics. You normally, let's say your influent water had enough nitrogen and phosphorus in it, and then because of a change of a product or a change in how something is operated, you don't have those anymore and you didn't know it, so you didn't have enough anymore. So that would be a change in wastewater characteristics. Next. How do you fix the nutrient problem? Obviously, you want to add what's missing. So if you find that you have a nutrient deficiency problem, to get back as fast as possible, you may want to add more like the first day or two. You may even double the amount that you would normally add. This could give you the biomass a jump start in getting back to normal. The recovery from a macronutrient deficiency is usually pretty fast. days, even a day. I just had a customer who was starting up a process and had preset the nutrient dosing equipment to what he thought was needed. And they started running, and the VFA was pretty high. And they noticed that the effluent nitrogen and phosphorus weren't showing up at all. They doubled it, tripled it, and finally got to a point, I don't remember how much it was, but they got to a point where they finally saw a residual of the nitrogen and phosphorus in the reactor effluent. And at that point, the volatile fatty acids started to reduce, and everything went back into a normal operation. The recovery from micronutrient deficiency is usually pretty slow. It could take weeks. And it takes weeks to even see a micronutrient deficiency. Another war story here. We had a customer, a pulp and paper mill in Canada years ago, where we had done, a year-long pilot study, won the big project, everything. The plant started up, and about 6 months after the plant started up, they noticed that the effluent volatile fatty acids were increasing. They called me up. I went up to see what was going on. The first day, I didn't see anything was a problem. The second day, I noticed that the level of the micronutrient level hadn't reduced overnight. And I said, "Is that pump running?" I couldn't see it and hear it. It was in a very noisy room, and it was out of reach. So they said, "Oh yeah, that pump died like a month ago, and since we're adding so very little of it, it didn't matter." Well, there's no nutrients in wood, let me tell you. You can't eat wood. It's not very nutritious. So I said, put the nutrients back on. They did that, and it took about 3 or 4 weeks before everything was back to normal. So again, if you have these deficiencies, the biomass activity will drop, which means that you have to operate at a lower F to M, which means you have to lower the loading to the reactor until the effluent VFA is less than 5. And at that point you can start feeding normally again. To keep this from happening, just again, maintain the equipment. Equipment maintenance is so important. And have backups. A lot of times you'll have a caustic pump and a nitrogen pump and an iron pump and a phosphoric acid pump. And a lot of times they can be interchangeable. So keep a spare one on hand. It's always good to have a backup. And make sure you don't run out of these nutrients. Make sure that the testing is done to determine that the nutrients that you need are there. And just keep going. Next. Okay, so now we're down on our flow chart to the bottom of the chart. We've determined that the system wasn't overloaded, there's no pH problem, there's no temperature problem, and all your nutrients are perfect. But I still have high volatile fatty acids. What's the problem? It's got to be something that's toxic or damaging or inhibitory to the biomass that's come down the line. And that's the only way you're going to know. You have to eliminate all the other reasons. And it's not easy to figure out, because we all know that when you call back up to the factory and tell them that there's a problem, that nothing's changed, nothing's been dumped, and nobody has spilled anything. Yeah, right. Okay. Well, that's not true. Learn to ask questions differently. And I'm going to even say, check with accounting. We had a customer who, a brewery in Mexico, who we did, again, pilot studies to begin with, built plant A. Everything worked really well. They built another one of our wastewater treatment plants at brewery B, which was exactly the same size as brewery A. So everything should have been the same. But we could never get brewery B's wastewater treatment plant to work well. It was always something wrong. And we knew it was something coming down in the water, but the customer didn't believe us. But we knew that was the case because the biomass that was used to seed the reactor that was left in the sludge tank was fine, but the biomass that was in the reactor and had been exposed to the wastewater wasn't good. After a long time, we finally asked, well, what's the difference? What are the different chemicals you use in plant A and B? And we compared the two. And there were several that weren't used in both, and we checked what was used differently in plant B, and none of them turned up to be toxic. We finally said, well, how much of these chemicals are you using? And they didn't have a good answer for us, and they actually had to go to accounting to find out how much of these compounds were being used. And it turned out that at Plant B, they were using 200 times more line lubricant on the bottling line than they were at Plant A. And at those concentrations, the line lubricant was toxic to the anaerobic bacteria. So that's why I say check with accounting even. So it sounds like a stupid thing to do, but it works sometimes. You can also, you notice I said we tested those chemicals, and we do toxicity testings in our lab to give us guidance in what might be toxic. And as a result of that incident that happened in Mexico, that brewery now will not allow any chemicals to be used in their facility without them having been exposed to toxicity testing first to prove that they won't kill the anaerobic biomass. Next. So what could cause an inhibitory or toxic substance to come in? And it can be anything. The list is endless, but it's always something in the wastewater. So it's something coming down from the plant. It's most likely a cleaning compound, because they're obviously, especially in food and beverage industries, and even in pulp and paper and chemical, you're trying to reduce the proliferation of bacterial growth. So they're cleaning with compounds that want to kill bacteria, and you have bacteria in the reactor, so those two don't necessarily go hand in hand. It could be flocculants and coagulants, or the combination thereof, and line lubricants like we just discussed, or a solvent that's used in a special cleaning. It could be anything. And it could also be the spill of something that, under normal circumstances wouldn't be in a concentration that would be harmful, but when it's spilled, it does get to be that concentration. So you have to be familiar with everything that's being used up in the production facility. Next. So, how do I fix? I know I have a toxic compound that's come down. So the first thing is I want to find out what it is if I can. Even if you can't, you want to stop it from getting into the system. So you want to stop feeding if you can and bypass the system. And at that point, you really need to rinse the biomass with fresh water to get that toxic substance out of the reactor, and so that the biomass isn't exposed to it anymore. At that point, you want to check to see if the biomass is still alive. You can do that by doing an activity test. If it is, you need to resume feeding at a very low rate until you determine how damaged the sludge is. And if it's damaged, again, you have to run at lower loadings until the VFA gets below 5 milliequivalents per liter. If the biomass is really dead and badly damaged, the best thing you can do and the fastest way to recover is to reseed the reactor. Next. So how can you keep toxicity problem from happening? Again, good communications with the factory to know what chemicals are being used, and if anything gets spilled or the usage rate changes is a good way to start. And again, any new compounds that are used in the factory, especially cleaning chemicals, get tested. Ask the people up in production to please have the compounds tested for anaerobic toxicity before they're used in the factory. I think that's it. Next. We're going to turn it back over to Greg to summarize up everything, and thanks for listening, guys.
Okay. Thank you, Jill. So just to go over again the 5 main things that are going to cause a system upset in an anaerobic reactor, as Jill pointed out, overloading, most likely due to some type of spill of product in the factory is the major contributor typically to overloading, and pH out of range on the high side or the low side. A caustic dosing pump being put in manual and being left on and going high, a caustic line plugging due to freeze issues because caustic freezes at 60 Fahrenheit, or a running out of chemical. Yes, when the pH control or caustic tank runs out on a Friday, you need to make sure you have another tanker coming in. You can't wait till Monday if you're going to have wastewater being fed. Temperature out of range. Typically we like to see our reactors run between about a 90 and 100. Once you start getting out of that range, you start to see some loss of activity in the biomass, especially on the lower side. So we need to keep the temperature in range. Lack of nutrients. Typically, you're not going to see this one instantaneously. You know, you have nitrogen or phosphorus addition as your macronutrients. Some of you guys probably add it. Some of you don't add it at all because they come down with the wastewater itself. You have micronutrient addition. As Jill pointed out, typically that's a very small amount of nutrients that you're adding, so it's tough to tell if the pump is on or not. So you need to, put some marks in your micronutrient tote or drum to sort of see over time if you're adding it. And finally, probably the most difficult one, which is toxicity. When all of your above parameters are within range, did the plant send something down, a chemical typically that is inhibitory or toxic to your biomass? If it's a complete kill, typically you know that. If it's a slow death, they're the ones that are much more difficult to figure out. If a chemical is coming down that only has, a kill ratio of 2 or 3%, it might take months to figure out that you're actually having a real problem. So those are the 5 main overloading factors for upsets. Some operational tips that we went over. A lot of this has to do with keeping your system maintained properly. If that's the operator himself or if that's getting on the maintenance department, keeping pH probes calibrated on a daily basis, keeping heat exchangers cleaned, making sure boilers preventative maintenance work is done, etc. If the system is maintained well and everything is functioning properly, your reactor should perform effectively. Keep the system in auto as much as possible. How many times things get killed because somebody put something in manual just for some short period of time, forgot to put it back? That's probably one of the #1 causes of pH out of control. All you people do it. Everybody does it. You throw something in manual real quick because you need to prime the pump. Something's not pumping. You throw it in manual to see what's working. You forget to put it back in auto. That's also why you want to keep your interlocks and your alarm systems up to date. If you have a nuisance alarm that constantly you're just ignoring, try to figure out how to, with your IT department or calling us up if we supply the system, how can we change those interlocks and alarms? They are there for a reason. They do help. They typically should be pretty simple to change the set points on them so they don't become nuisance alarms or nuisance interlocks. Nobody likes them. When we're commissioning and starting up systems, we try to work through all those. But when you're out in the real world, some interlocks that look great on paper, when the process engineer in the real world don't work, we need to be able to change them so you don't have those issues. And finally, make sure you do the testing. You can't tell if you have a problem if you don't have any data to know if you have a problem. There's some key lab testing, the VFA, the influent and effluent COD analyses, doing your lab pHs, to confirm your probes, etc. Without good data and without good data collection over the long term. It's not just a day-to-day that you take a sheet and you throw it in a drawer. As Jill will tell you, occasionally you go out to some facilities and you ask for their data, and somebody opens up a drawer and hands you about 150 sheets of analytical data pages that they have sitting there, and they say, here, they don't have it in an Excel spreadsheet, they can't trend it, they do the data, but they actually don't look at the data on a day-to-day basis. So it's important that you do the testing, you catalog the testing, and you know what the testing means.
Okay, we'll now transition to the second half of our webinar. It's going to be our question and answer portion of our webinar. You'll see there'll be a panel in the right-hand side, so if you want to just enter your questions in there. We'll give you a few moments to write any questions that you may have to our presenters. In the meantime, just wanted to mention that our next and final webinar for the year for this series will be held on Thursday, November 15th, 2018. So we really hope you can join us. Please save the date, put that in your calendar. In terms of what the content will be, we always wait to see the survey responses from the webinars before we go ahead and make a decision on what the content will be. So go ahead and write any kind of feedback or things that we should go and present on when taking that survey, so we'll make sure that we're meeting your needs as operators.
So just as we wait a little bit here, as some of you may type in some questions and they come up on TJ's screen here, just want to go over a couple other things. Jill mentioned a lot of different things out there of troubleshooting things and some experience things. just some things that I also would like to add to that. When it comes to inhibitory substances and chemical suppliers and going up to the production facility and them obviously always saying nothing happened, everything's perfect, we're angels. Ask the chemical supplier. A lot of times the chemical supplier is the one supplying the chemical, so they know if they're using more than they should. Or have the operator go look at the tank levels in the actual facility, to see what is the level of the tank yesterday, or do they remember what it was yesterday, to figure out if they used a whole lot more chemical than normal. So asking your chemical suppliers or understanding what the tank levels in the production facility are for certain key chemicals is important. For overloading, look at the biogas trend. You guys should know what your biogas should be sort of on a daily basis. All of a sudden it spikes way up. That means the only way biogas can typically come is from COD. So if you had a huge biogas spike, that typically meant that you had a big COD spike. You might also be able to see a big COD spike in your EQ tank pH trending. If there's a lot of sugar gets sent down the drain, you're going to have a lot of acidification. So if all of a sudden you see a huge pH change, that usually means something happening in your EQ tank. If you do have problems, as Jill said, sometimes the simplest way and the fastest way to get out of it is to flush it out. Take hoses and put them down the, trench drains so you flush through your system. If that's possible to do, that sometimes is a quick way, sometimes a simple way to get out of the problem. Make sure that when you do that, usually your hose water is pretty cold, that you have heat available to keep your system heated. And it won't be the first time in the world that somebody turned on the fire hose, put 65-degree water down the drain, and the reactor temperature goes from 95 down to 70, and all of a sudden they have a temperature problem then. So the key is to put enough water down that you can keep heated. Another thing would be caustic pumps. Keep an extra one on hand. If you need a temporary setup, sometimes if your pH gets crazy out of control, you can't dose enough in there, put a second pump in. Can you dump a little caustic down the drain, etc.? That's another thing that can happen. If you don't have heat for some reason, can the factory dump some hot water down the drain? Won't be the first time the factory sort of leaves open a bleed valve on something, a boiler line or something like that, and put some hot water down the drain if your boiler is temporarily unavailable. So those are some other things that we've seen operators do in the past. TJ has some questions here.
Okay, thank you. Jill, a question for you is how long can an anaerobic digester sustain itself with an outage of a macronutrient feed?
Typically, the macronutrients, you're going to see a change within days. I mean, it's that quick with nitrogen and phosphorus. If it's a real issue, you'll see it in a couple of days, and it doesn't take long to get it back in line once you put the nitrogen and phosphorus back in.
Okay. And another question too is, can you explain how to test for anaerobic toxicity of new chemicals?
So I'll take that one.
Go ahead.
We have in our lab a setup specifically for chemical toxicity testing. It's probably something that's not really easy to do without a setup in your own lab. So typically what vendors will do, chemical vendors sometimes, or plants themselves, is if you send us the chemical, we can do an anaerobic toxicity testing in our lab. We have some good biomass. We put chemicals at different concentrations in, and then we can measure the activity rate of it. Typically, it takes about 1 week to do the chemical toxicity testing, and we recommend that people do that if they're bringing in new chemicals into their facility. So typically, you have to go to an outside lab. We do it in order to do chemical toxicity testing. That's something you can actually do typically in your own lab.
Okay, we have one person on the webinar that's saying that they have higher nitrates and nitrites in the EQ tank, and after checking with the plant, they found that there is no nitric acid being sent. So could there be another cause for these spike in levels?
Geez, I don't know of any. Usually it's because they're using some sort of nitric or nitric acid in the facility. I can't imagine that you form nitrates and nitrites in an anaerobic EQ tank. In fact, the nitrates and nitrite concentrations should be reduced under anaerobic conditions, especially if there's a lot of COD associated with it. Do you know of anything, Greg?
I mean, I would say nitrate and nitrite, if it's coming down the drain, I mean, it would have to come down the drain. We're not going to create that in the system. The only other question I have, I don't know if this person has an aerated EQ tank. That could be a issue. Typically, in an anaerobic system, your EQ tank would not be aerated. Aerated EQ tanks are very popular before like a DAF or before an aerobic system, but obviously air or oxygen really is toxic to anaerobic bacteria, so you do not want to have an aerated EQ tank. So in an EQ tank that is just mixed with like a side entry mixer, you should not have any nitrate or nitrite forming. So it has to be coming down from the plant, or you have an air line somewhere that's creating it.
Okay,
wait a minute, or check to see if there's I don't know what testing you're using to test for the nitrates and nitrites, but maybe there's some interference in the testing, some compound in the wastewater that could interfere with the results of your nitrate and nitrite test. Go ahead, TJ.
Okay, we have another question, and it has to do with struvite on the effluent side instead of the solid side. So can you guys comment on struvite?
So struvite, for those of you who don't know, is magnesium ammonium phosphate, and it forms in reactors that have high hardness coming in with them. And typically you will see it form in an anaerobic reactor, because an anaerobic reactor has reducing conditions and the pH is such typically that you will have formation of struvite if your magnesium and ammonium levels are high enough and you have phosphorus. So that's why you're going to see it forming more on the anaerobic effluent side than on anything on the influent side, because typically your influent has a pH that's more in the 5 or 6 range, where you don't have the conditions for it. Struvite is also formed in places typically where there's high levels of turbulence. So typically you will see them formed at elbows in piping. You will see them formed at maybe some valves or other places where you have turbulence in the pipe. So there's not a huge amount you can do. I mean, struvite's a very difficult thing to handle. I would say the best thing there would be to contact Greg after this webinar separate individually, and we can go over your situation more in detail. But struvite is something, yes, you're definitely going to have on the anaerobic side, not on the influent side.
Great, thanks. And one basic question, we had someone come in a little bit late, and just can you comment and review the F to M optimal range?
There is no well, 0.5 is like the general, what we say, typical range for high rate anaerobic wastewater treatment plants. Each facility is different. I've had some plants that are able to operate normally and regularly at an F to M of 1, 1.2. There's other facilities that can only run at like 0.25 to 0.3. It all depends on the characteristics of your wastewater and the amount of and type of substrate that the biomass is exposed to.
Okay. Well, that seems to be it for the questions. So at this time, I'm going to conclude the webinar. Thank you for everyone for joining us this afternoon. If you have any additional questions and would like to follow up, feel free to email myself or Jill Jordan. Her contact information is on the screen. Otherwise, be on the lookout for our invite to our final webinar for this year. So we hope to see you sign up for that. Again, thank you all and have a great afternoon.